We've got three forces alongside over here. None of them have worked with a bearing off the north line. So if I were to take a north line over here, the bearing of A would be 90 degrees. The bearing of B would be all the way around. If you think about it, you would actually just need to take 21 off 360. So you land up with an angle that is 339. And then this one over here, if you start on a bearing line, you can kind of think of that as being 90 degrees, that's 90 degrees, and then that's 180, meaning that you've still got another 60 degrees over here, which means there's 30 degrees in there, which means there's 90 degrees there. So it's 180 plus 30, and all the way around is going to be 210 degrees. So, when we ask the questions, which of the forces alongside can be described as a bearing of 210? C is your correct answer. Which of the forces alongside can be described as being on a bearing of 90? A is your right answer. Which of the forces alongside can be described as 21 degrees west of north? So, if we're going to be going west of north, we need to go from the north line and then go towards the west. And if I do that here, I would land up all the way around at 270. Starting here, I would land up with 150. Starting on this one over here, I've got 111, so we're going to take 90 degrees from that, and we go 21 degrees. So B is 21 degrees west of north. And which of the following describes starting at the west line and then going 69 degrees towards the north line? So if I started at the west line and went 69 degrees, well, 90 minus 21 is 69 degrees, and go 69 degrees towards that north line. So starting point west, 69 degrees north, B is the correct answer. If a scale of 10 millimeters represents 1 Newton, how long would I need to make this 9 Newton line? Well, I would need to make it 90 millimeters. 1 Newton, 10 millimeters. 2 Newtons, 20. 3 Newtons, 30, etc. until you get to 90 millimeters. They don't give that as an answer. So we better look at some others. That's the same as 9 centimeters. It's the same as 0,9 decimeters, and it is the same as 0,09 meters. What have we got? B is my correct answer over there. If a scale of 10 millimeters represents 2 newtons was used, how long would the 7 Newton line be? Well, 2 newtons, 10. 3 newtons, 4 newtons is going to be 20. 5 newtons, 6 newtons is going to be 30, and the last little bit, the 7th Newton, is only half of that, so it's going to land up being 30 and a half, 35 millimeters. Do I have that as a choice? Yes, I do. B. If I wanted to know the direction of these two lines over here, the first one is on a bearing of 10 degrees, the 9 Newton, and the 7 Newton is on a bearing of 60 degrees, or it is east 30 degrees north. In other words, starting on the east line, go 30 degrees north. Or I could have said 30 degrees north of east. So there are quite a lot of different options there. Let's see what they ask us. If a scale of 10 millimeters represents 0.5 newtons was used, how long would the 9 Newton line be? So 9 newtons, 0,5 is going to be 10 millimeters. 1 Newton is 20 millimeters. 2 newtons is therefore 40. 3 newtons is 60. And if I go all the way up to 9 newtons, I'm going to land up at 180 millimeters. Again, that's not given to me. I need to go to centimeters. That's 18 centimeters. Which of the following describes the 9 Newton line on a bearing of 10 degrees? And that sounds like a very good description, actually. We just discussed it a minute ago. Which of the following directions describes the 7 Newton line on a bearing of 30 degrees? Definitely not. It was on a bearing of 60 degrees. 30 degrees north of east. Starting on the east line, go 30 degrees towards north. That looks great. Starting on the east line, go 60 degrees towards the north. No. Starting on the north line, go 30 degrees towards the east line. No. So B was your correct answer.